say, actually, I'm going to start that and move it over some, because if I have it on two separate lines, it won't look right. Okay, so 3x to the fourth plus 12x to the third, h, 18x squared, h squared plus 12. That didn't make a whole lot of difference. X to the third plus 3h to the fourth plus 4x squared plus 8xh plus 4h squared minus 7x, plus 7x plus 7h plus 4, and made a little bit of difference, minus your r of x, which is 3x to the fourth plus 4x squared plus 7x plus 4 all over h. Okay, so now we get rid of our parentheses.
We're going to have one that's big on the test.
Possible. They won't all be that big, but there'll probably be a couple. Yes?
In the very last section,
Mhm.
can you just read that off of me?
Which one? This one?
Yeah.
Oh, this is just our r of x, which is this here. So 3x to the fourth plus 4x squared. Yeah, it's a little bit snug in there. Okay. So now we get rid of all of our parentheses. So the limit as h approaches 0, this is all positive, so we can just write this right on out. 3x to the fourth plus 12x to the third h plus 18x squared h squared plus 12xh to the third plus 3h to the fourth plus 4x squared plus 8xh plus 4h squared plus 7x plus 7h plus 4. If we distribute that negative to all of those terms, minus 3x to the fourth minus 4x squared minus 7x minus 4 all over h. That lonely little h. Let me zoom this in a little bit. Oh, not that much. Okay, you can stop. You can stop. You can stop. There you go. All right, you can stop. There we go.
Should it be a +7 somewhere? Like when we solve it out, I'm trying to.
7x is right there.
No, because then it's going to get minus by 7.
Yeah, so it gets rid of it.
Yeah, because actually now, once we get rid of our parentheses, is where we start canceling stuff. Okay, so here you have a 3x to the fourth minus 3x to the fourth. And you have 4x squared minus 4x squared plus 7x minus 7x plus 4 minus 4. So you're left with the limit as h approaches 0, 12x to the third h plus 18x squared h squared plus 12x h to the third plus 3h to the fourth plus 8x h plus 4h squared, and everything, plus 7h, and everything else has canceled out already, all over h. So remember, this step is where things cancel out. And this step is where we factor our h out of the numerator. Limit as h approaches 0. So if we factor out an h here, we have 12x to the third plus 18x squared h plus 12x h squared plus 3h to the third plus 8x plus 4h plus 7 all over h. And this is where that cancels. Move that up just a hair.
So is that, so then you would put the 0 after h, right?
Yep, then you can just plug in the h with, well, direct substitution.
But isn't that make all those ones that have multiply of h just 0?
Yep, all those just become 0.
I was just making sure I did it right.
So 12x to the third plus 18x squared h plus 12x h squared plus 3h to the third plus 8x plus 4h plus 7. Then you plug in all of those zeros, that disappears, all those disappear. So you're left with 12x to the third plus 8x plus 7. Okay, and that's your final answer. Now, word of warning, because I go through this every year and I know somebody's going to try it. Yes, there is a shortcut to find this derivative, but if on the test you solve it any other way other than limit definition and it says using the limit definition, you will get 0 points for that problem.
If you skip steps,
Hmm?
like if you let's say like that part where you cancel out h, if you did it without actually writing down that you canceled out h, do you mark that down?
With that step, I'd have to see it. So as long as I see the, as far as like where you plug it in, like, let me see.
For example, like this. H here, and then like, as you can see, I didn't write down the h outside. That's kind of that. Maybe I have.
Yeah, I want to at least see where the h canceled out.
Okay, just making sure because I sometimes do that.
Oh, sorry about that. Let me zoom in. Yes.
So for example, the step where you cancel out the h's,
Mm-hmm.
Can we just cancel out the zeros on that same step as well?
Well, if you, like, if this step here,
So if you combine both of those.
oh yeah, then if you say, if you cancel out, if you put like using direct substitution or if h is equal to 0, then you just go from there, that'd be okay. So as long as I see like where the transition came from.
So, I guess I'm kind of lost in this last step.
Mm-hmm.
So, how did you cancel out?
Oh, this one was just direct substitution of h equals 0. Because remember, you couldn't plug in h equals 0 as long as you had it in the denominator. Once you got rid of it in the denominator,
Right.
now you can plug it in. All right. So any other questions on this one, or outside of being really, really long? Yes.
So this is technically the definition of a secant line or whatnot, or?
Nope, that's your derivative, which is the instantaneous rate of change
Okay.
at x equal whatever. So if we had this function here, so if we wanted to find out the rate of change at x equals 3, we just plug in x equals 3 into this equation, and it'll let us know the rate of change.
Okay.
All right. Any other questions, or everybody's okay? All right. Oh, make sure. Okay, now for this one, let's say if we are given t of x equals, oh, sorry, that, 3x minus 5 over 5x minus 10. And we want to find the t prime of 7. Using the definition of a derivative. Zoom this out just a hair. Okay, so the first thing you want to do is get your t of x plus h. Okay, so we know all you have to do is replace all your x with x plus h. And I'll put this right next to it just to save space. So t of x plus h is going to equal 3x plus h minus 5 over 5x plus h minus 10. I'm going to leave it like that for now. I'm not going to distribute the 3 and the 5 just yet. And I'll show you why in a second. Oh yeah. Trust me, I went through multiple pages and then say, oh, you know what, it would have been easier if I did this last time. And had to go back and do it all over again. Okay? So since we know that t of x is equal to 3x minus 5 over 5x minus 10, we plug it into our limit definition equation. Or formula. Okay, so we know that t prime of x is going to equal the limit as h approaches 0, t of x plus h minus t of x all over h. Which is going to equal the limit as h approaches 0, or t of x plus h, we know that's up here. So that's 3x plus h minus 5 over 5x plus h minus 10 minus our t of x, which is 3x minus 5 over 5x minus 10 all over h. Okay. So the first thing you want to do here is, since you have two fractions, is you want to get like denominators. Now I'll put that down here. So if you have the limit as h approaches 0, and I'll give it a little bit of space. Say 3x plus h minus 5 over 5x plus h minus 10 minus 3x minus 5 over 5x minus 10. To get like denominators, you just multiply this one by 5x minus 10, and this one, well, 5x minus 10 over 5x minus 10, and this one, 5x plus h minus 10 over 5x plus h minus 10. Hence why I left a little bit of room. So 5x minus 10 over 5x minus 10. And this one, 5x plus h minus 10. over 5x plus h minus 10. All over h. So for each one of these, we're just going to do the FOIL method. At least in the numerator. We don't have to worry about it in the denominator. Okay, so the limit as h approaches 0, if we do the FOIL method up here, we have 5x times 3. So we have 15x times x plus h. Your outer, 5x times negative 5 is negative 25x. Your inner, you have negative 30 times x plus h. And your last is negative 10, and negative 5 is positive 50. Minus the FOIL method for these two. 3x times 5, so you have 15x times x plus h. You have your outer, which is 3x times negative 10, which is negative 30x, plus your inner, negative 25x plus h, and your last, which is positive 50. All over your common denominator of 5x minus 10, 5x plus h minus 10, and all of that is over h. Now if you wanted to, you could just make h a part of that one, so that would make it a little bit neater. So you have the limit as h approaches 0. Now we can go ahead and distribute our 15x and our negative 30 and all of those. Get rid of those x plus h's. But having that x plus h there just made the FOIL method a little easier. Okay, so if we distribute our 15x, we have 15x squared plus 15xh minus 25x minus 30x minus 30h plus 50. So if we distribute this here, that negative 1, we'd end up with negative 15x squared minus 15xh plus 30x plus 25x plus 25h minus 50. All over. So we can just have the h since it's in the denominator. H times 5x minus 10, 5x plus h minus 10. Okay, so now things should start canceling off. You have 15x squared minus 15x squared. You have minus 25x plus 25x. You have minus 30x, 30h right there. Wrong one. Clean that up a little bit. There we go. Minus 30x plus 30x. You have minus 50, well, plus 50 and minus 50. And I believe that's everything that cancels off. So the limit as h approaches 0, 15xh minus 30h minus 15xh. Didn't miss. How'd I miss that one? Yep, so those two should have canceled off. So here you get minus 30h plus 25h all over h times 5x minus 10 times 5x plus h minus 10. And you can just combine those two, which gives you negative 5h. And
Why did you combine that h with the numerator there?
oh, just to make it neater. So it would be just like saying if you have 3 over 5 divided by h, if you rewrote that as 3 over 5 divided by h, then if you divide your fractions, you write down the first one. Turn division to multiplication, then you flip the second one, so h over 1 becomes 1 over h. So you have 3 over 5h. So that denominator just joins that denominator. Does that make sense? All right. Okay, so we have the limit as h approaches 0 of negative 5h over h times 5x minus 10 times 5x plus h minus 10. So that cancels out, which leaves us with our t prime of x equals, oh, still have a step to go. Don't want to skip any just yet. Okay, so you have our limit as h approaches 0 of negative 5 over 5x minus 10 times 5x plus h minus 10. So if we use our direct substitution and plug in the h equals 0, we end up with our t prime of x equals negative 5 over 5x minus 10. And if that h becomes 0, you get 5x minus 10 again. So you have 5x minus 10 squared. Okay, so we're like 95% done. You can, but you don't have to. Okay, because we have our third step, we have to find t prime of 7. Okay, which is equal to negative 5, or 5 times 7 minus 10 squared. Okay, so you have negative 5 over 35 minus 10 is 25. 25 squared is 625. So you have negative 1 over 125. Okay, and that would be your final answer. Yes?
Can you show again real quick the denominator for h, the little side note you did on the other piece of paper?
Oh, this one?
Yeah.
Oh, whenever you have, let's say,
I just wanted to make sure I had copied down the quick.
okay.
Thank you.
Mhm. You got it?
Yep.
You get, all right. Okay, so any questions on this one? Yes.
The second, well, I don't know about the second step, but the second limit thing down.
This one?
How do we start getting rid of the x plus h?
Oh, we just distribute the coefficient in front of them. So here we distribute the 15x. So we have 15x squared plus 15xh.
Okay,
Oh, do you have a question?
Oh, yeah. How did you get the, in the denominator 5x minus 10, squared?
Oh, because when you plug in the h equals 0 here, you get 5x plus 0, so that's just 5x minus 10. And you had 5x minus 10 here.
Oh, okay, there's no way, did I just? Oh, I see, okay. Yeah, okay.
Yeah.
Gotcha.
So you could have wrote it as 5x minus 10 times 5x minus 10, which
Yeah.
just combine them.
And you didn't wanna do the FOIL method with that,
Mhm.
just do the direct substitution.
Yep, exactly.
Okay.
Yes.
There a quicker way.
Oh yeah, there it is. It is.
Good.
But using the limit definition, you have to go through kind of the lengthy way before you can do the shortcut. Oh, it's a shortcut way to get that in every bit of maybe 30 seconds. So,
Isn't that the,
yep, just the power rule of derivatives.
I thought you wouldn't use power in that instance, you would use the one where it's like the power, or the derivative of something minus the derivative of something, and then all over that derivative. Am I thinking of something else?
Maybe the quotient rule.
Yeah, I think you're thinking of the quotient rule.
We have to use that with this.
With this one, you would, yeah.
Oh, yeah, that makes sense.
Yep. All right. Any other questions? All right. Okay, so say for example, okay, so let's say if we wanted to find the derivative of,
If you know sustained derivative, then it's whole page now.
well, if they say derivative using the limit definition, then it gets lengthy. But just derivative itself, you'll see it comes out to be not too bad. 2 over t using the limit definition of a derivative. Okay, and I'll let you start on this one. Excuse me. Oh, we're at 28 minutes. Might as well